Hello, and welcome to the KC3 review. Let's get started. Number 1. Samuel pays $59.99 plus 25 cents for each minute over 450 minutes for a cell phone plan. Monica pays $64.99 plus 10 cents for each minute over 450 minutes on her cell phone plan. Which system of equations represents the situation? Let X represent the number of minutes over 450. What I'm going to begin with is looking at Samuel's information. Samuel pays $59.99 plus 25 cents for each minute. That means we should have a $59.99, a plus sign, and an X next to the 0.25. So let's see. Letter A I'm going to cross off because that has an X next to the 59. Same with letter B. Letter C, I do have $59.99, but it's plus 10 cents. It only matches with letter D, so letter D is my answer. Number 2. Jim pays $59.99 plus 20 cents for each minute over 450 minutes. For his cell phone plan, Ben pays $64.99 plus 15 cents for each minute over 450 minutes for his cell phone plan. Which system of equations represents the situation? Let X represent the number of minutes over 450. Let's begin with Jim. Alright, so Jim has $59.99, so he has to pay that no matter what, plus 20 cents over each minute. That means I should have $59.99, a plus sign, and then a little X next to the 20. I see that option happening only in letter D. No. My bad, I meant to say letter B. Letter B, not letter D. $59.99 plus 20 cents per minute. Number 3. How many solutions does this system of equations have? Now what I would like you to do here is whip out your calculators, then click Menu, then 3, then 2, and Enter. Make sure you're using the white X and Y on the bottom of your calculator and the equal sign that's under the yellow control button. Once you enter this in, you should have a very funky answer. It has a couple of letters C, like cat, in it. When you have an answer like that on your calculator, the solutions are infinite. Or you could just draw an infinity symbol. Now, if you plugged it in and you got something that said no solution, that would be the exact answer. Our calculators just cannot tell us infinite solutions. They give us a funky answer. But they will tell us if there's one solution or if there are infinite solutions. If there's no solution. Alright, so that means for number 4, I'm doing the same thing. Menu, 3, 2, Enter. And this time, what popped up for me was 6,16, which means I have one solution. Number 5, solve the following system by linear substitution. All right, so what we're going to do is we're going to take the y equals equation and we're going to substitute it into the first one. I'm going to rewrite it just because I just like to do it that way, and then we'll get started. Okay, so instead of y, I'm going to substitute in 4x minus 18 because that's what y is. Now I'm going to solve it like I do any other equation because this is very nice. We only have x's to deal with now. The first thing that I notice on the left-hand side is the 3x and the 4x. 3x's plus 4x's give us 7x's. I bring down the minus 18 and the equal 17. Now our goal is always to get the variable by itself. So my next step here would be to add 18 to both sides. I'm left with 7x on the left-hand side equals 35. And our very last step is to divide both sides by 7. X equals 5. Perfect. We have one of our variables. Now that we know x, we can actually use this equation to find out what y equals. I'm going to, well, you could really use either of the equations. I think this one's just a little easier to use since it's a y equals. Now instead of x, I'm going to substitute in the 5 that we got. Right. Parentheses mean multiplication, so 4 times 5 is 20, and 20 minus 18 is 2. So our final answer is written as 5, 2. Don't forget we're keeping this in alphabetical order, x, y. Let's try that again. We are once again going to do some linear substitution. I'm going to take the bottom equation, the y equals, and I'm going to plug it in to the top. So I'm going to rewrite it right here for clarity's sake. Hi. And let's plug that in. Alright, so we've got 3x, and instead of y, we're going to write 2x plus 2, and it equals 17. Alright. On the left-hand side, do you see two things that we can put together? I see this 3x and the 2x. 3x's plus 2x's gives us 5x's, and I bring down the plus 2, and the equals 17. Our goal as usual is to get x by itself, so my next step is to undo the plus 2. How do we undo the plus 2? That's right, we're going to subtract 2 from both sides. So I'm left with 5x equals 15, and our final step is to divide both sides by 5. X equals 3. Wonderful! We have x. I'm going to use this equation, this y equals equation, to find y, because I think it's going to be a little easier to use. It doesn't really matter which one you use, but this will just make things a little easier for you. Alright, so instead of x, I put in a 3. Parentheses mean multiply, so 2 times 3 is 6, and 6 plus 2 is 8. So our final answer is 3, 8. Don't forget, it's x, y. Alright, now let's solve these systems for 8 and 9. They're through linear combination, but let's practice using our calculator. So whip out your calculator, menu, 3, 2, enter. Carefully put in both of these equations, and once you finish, click enter again, and you should get the answer, letter D. If you don't, please come ask me or your teacher what you entered wrong. Alright, let's do number 9. Same way, you're going to take out your calculator, or hopefully it's already out, menu, 3, 2, enter, and you should get the answer, letter B. If you don't, please ask so we can see what happened. Number 10. Solve this system through linear combination / elimination. Now when we're doing this, we are looking for opposites. Now, on my x's and my y's, I see kind of opposites. There is one negative and there is one positive, but they're not the same number. I feel like doing the x's this time, so let's do it. What I'm going to do is I'm going to force them to be opposite. Now, since we already have a positive and a negative, I just need them to be the same number. So I'm going to multiply the whole top equation by 2 and the whole bottom equation by 3. The reason is I want to get rid of my x's. So let's see what happens when we distribute that. 2 times negative 3x is negative 6x. 2 times y is 2y. And 2 times 10 is 20. Alright, let's distribute the bottom. 3 times 2x is 6x. 3 times negative 7y is negative 21y. And 3 times 6 is 18. Now our goal was to make those x's opposite, Success. All right, let's add going up and down. Our x's cancel. Perfect. That was kind of the point. 2y plus negative 21y gives us negative 19y. 20 plus 18 is 38. And I'll finish this up by dividing by negative 19. Y equals negative 2. Wonderful. Now that we have y, we can plug it back into either equation to find x. I feel like using the top equation to find x. Let's do that. So negative 3x plus y equals 10. Notice that I'm using the original one. Just a little easier to do that because the numbers are smaller. All right, so we found y, so let's plug it in. So instead of negative 3x plus y, I have negative 3x minus 2 because y was negative 2. I don't see any like terms that I can combine, so I'm just going to continue by adding 2 to both sides. So negative 3x equals 12. And let's finish by dividing both sides by negative 3. X equals negative 4. We write our answer as negative 4 comma negative 2 because it's x comma y. Let's do another. So once again, we're doing linear combination / elimination. I notice that both my x's and my y's have opposites. So I can really work with either one of them. Since we did x's in the last problem, let's work on eliminating our y's in this one. So one is positive, one is negative, but let's make them the same number. So I'm going to multiply the whole top equation by 3 and the whole bottom equation by 1. That doesn't look like a nice 1. There we go. That's better. Okay. So hopefully by doing this, we should have some opposites. Let's see what happens. 3 times 7x is 21x. 3 times negative y is negative 3y. 3 times 15 is 45. 1 times negative 6x is negative 6x. 1 times 3y is positive 3y. And 1 times 15 is 15. So let's see, did our y's become opposites? Yes, they did. Fantastic. This means they cancel, and we can add everything going up and down. 21x plus negative 6x leaves us with 15x. 45 plus 15 gives us 60. And let's finish up finding x by dividing both sides by 15. X equals 4. Very nice. Now that we've found x, we can find y, and really we could use either equation to find it. The top one looks a little bit more appealing for me, so I'm going to use it. Okay, so now that I have x, I am going to plug 4 in instead of x. Parentheses mean multiplication, so I have 28 minus y equals 15. I'm going to subtract 28 from both sides. I'm left with negative y equals negative 13. And then to get rid of the negative in front of y, I'm dividing both sides by negative 1. Y equals positive 13. So our answer is 4 comma 13 because it's x comma y. Don't forget to keep it in alphabetical order. All right, let's take a look at number 12. Let's explain when graphing, substitution, or elimination are good to use for systems. Graphing is good when both equations are y equals, because then it's really easy for us to see what the slope is, what the y-intercept is. It's easy for us to use graphing utilities to graph them. So just plop them in, and they are graphed, and then we can see the type of solution we have. Substitution is good when one equation is y equals or x equals. So one equation is ready for us to substitute into the other. Linear combination is good when both equations are ax plus by equals c. So they're in standard form. Or I would take this answer, there are opposite variables. Linear combination is one of the better ones. This one can be used whenever. Graphing also works, but it's not as easy to do by hand. But linear combination / elimination is always really easy, and it just, okay, maybe it's not really easy for everyone, but I think that it's one of the good ones. It can be used for almost any situation. All right, number 13 and 14. What we're looking for is the inequalities that represent dashed or solid lines. So let's review that. When we have a symbol like this or like this, we have a dashed line or a dotted line. I prefer calling them dotted. So our line on a graph will look like this. If we have a symbol like this, we have a solid line. The way I remember it is a solid line on the graph has a solid line in the symbol. So in number 13, when it asks you which inequality represents a dashed line, it would be B and D. And number 14, when it asks us to identify a solid line, we're looking for the symbols with a solid line, A and B. Number 15, let's write the inequality that is represented by these graphs, or 15 and 16. Okay, so I know that I will have the following type of inequality. I'm going to have a y, some sort of symbol, mx, and a b. Y is y, x is x, m is your slope, b is your y-intercept. So first let's figure out what the symbol is going to be. The way I do that is by placing my pen or pencil anywhere on my line, and you're going to pull straight up or straight down. So which way is it shaded? It looks like I would have to go straight down to get to the shaded area. So my symbol is less than. Since it's a solid line, my symbol gets a solid line. If my graph was shaded going up, that would be a greater than symbol. All right, next let's take a look at the slope. The slope we find by using two nice points that are right on the corners. So here's a nice point right here, and there's another one there. So let's do rise over run. I go up 1, 2, and then 1, 2, 3 to the right. So 2 over 3 is my slope. And lastly, let us identify our y-intercept. Our y-intercept happens right here at -3. That's it. Let's try it again. Once again, we're going to have a y, some sort of symbol, slope times x plus y-intercept. Okay, so let's begin by deciding on our symbol. I'm going to put my pencil on the line, and we're either going to draw up towards the shaded or down towards the shaded. Well, it looks like drawing down got us straight to the shaded area. Down is less, so this is a less. Since this is a dashed or dotted line, it does not get a solid line underneath. Next, let's do our slope. Let's find two nice points. Let's do this one and this one. So we go down 1, 2, 3, 4, 5 over 1. Down 5 is -5 to the right 1. And our y-intercept actually happens right up here. I believe that is at 9. That's it. Number 17. Select all the points that are solutions to the system. What we're going to do is we're going to graph them all and see which points land in the shaded area or on the solid line that's associated with the shaded area. All right. A is negative 2, 0. That is letter A. Letter A does not work. It's not even in the shaded area. 0, 3. Letter B. Letter B is an option. It's on the solid line that is part of the shaded area. Letter C. Negative 3, 4. Beautiful. Here it is, right smack dab in the middle of the shaded area. D is negative 2, 1. That's right there, so that doesn't work. And lastly, E is 0, 0. Does not work either. Let's do the same thing for number 18. A is 0, 0. Nope, that wasn't even close. B is negative 4, 0. Beautiful, that's on the solid line and it's part of the shaded area. C is negative 4, negative 5. Wonderful, that works as well. D is negative 2, 4. Not even close. All right, not too bad. Number 19. Which system of inequalities is represented by the graph? Well, let's see how it goes. Okay, so the first thing I'm looking for is that I need one solid line and one dotted line. Unfortunately, I can't really cross anything off here. Each one of these options has a symbol that is associated with a solid line and one is associated with a dotted line. So let's begin by looking at the solid line. This solid line is shaded downwards, which means I should have a less than or equal to. Let's see what I can cross off. I can cross off letter C. Every other one has it. Okay, that's fine. Onwards we go. How about this dotted line? This dotted line seems to be shaded up, so I should have a greater than symbol. Let's see what I can cross off. Nothing. Well, that's not helpful now, is it? Let's continue. Okay. Let's look at the y-intercepts. That's the next thing. All right, y-intercept for the line that I labeled the solid line is right here at negative 1. So I should have a minus 1 with my symbol. That has it. Ooh, letter B doesn't. It has a plus 3 with my symbol. And letter D has it as well. Okay. Let's see what we can get from the dotted line. The dotted line has a y-intercept at 3. They both have it. Okay. Now, A and D are very similar, except for this dotted line has a negative 2x and this one has a positive 2x. Now, take a look at our dotted line. It's going downhill, so A would be our correct answer because it's a negative 2x. They're not both positive lines. Number 20. Let's do the same thing. Here I see two dotted lines, which means both of my symbols should not have solid lines. Which, oh, beautiful. I can cross letter D off right away. Okay. One of my dotted lines is shaded going up. So I should definitely have a symbol like this. Let's see. Ooh, I can cross B off because that doesn't have it. All right, perfect. My second symbol, my second line, is also shaded up. So both of my symbols should be pointed that way. Letter C is our answer. Nice and easy. 21. Gino wants to purchase a gym membership. He has no more than Y dollars to spend. Total Fitness charges an initial fee of $100 plus $30 a month. Gymania charges an initial fee of $25 and then $50 a month. Let's write a system of inequalities, and X is going to represent the number of months. All right. So the first gym, well, first of all, Gino has Y dollars to spend. Can Gino spend more than Y dollars? No. That means I should have a greater than symbol because The amount of money he has is the most he has. Can Gino spend exactly Y dollars? Why not? So each of them gets an or equal to. All right, now let's take a look at Total Fitness. Total Fitness charges an initial fee of $100 plus $30 per month. So Total Fitness gets $100 no matter what, then plus $30 per month. Gymania has an initial fee of $25, so you got to pay that no matter what, and then you pay $50 a month. Success. 22. Alfonso wants to purchase a pool membership for the summer. He has no more than Y dollars to spend. The aquatic club charges an initial fee of $75 plus $20 per month. The swimming hole charges an initial fee of $15 plus $65 per month. Write a system of inequalities that can be used to determine which company offers the better deal. Let X represent the number of months. Okay? So like Gino, Alfonso only has Y amount of dollars. He has no more than that to spend, meaning Y has to be the largest amount of money. He can't spend the money that he doesn't have. If Alfonso wanted to, could he spend exactly Y amount of dollars? Sure, why not? So we put an or equal to. Right, let's take a look at the aquatic club. The aquatics club charges $75 no matter what, plus $20 per month. Swimming hole charges $15 plus $65 per month. All right, not bad. Well, let's move on to our last two problems. What we're going to be doing here is we're going to be completing the system by writing the appropriate symbols. So this is how I figure it out. The first inequality that I'm looking at has a -2 in it, which means it crosses -2 on the y-axis. So we're talking about this line right here. This line is shaded up. That means greater than. It's dotted, so it doesn't get a line underneath. The next one has a -4, which means we cross at -4 on the y-axis. This is the line we're looking at. The line is shaded up, so there's another greater than symbol. The next line has a +3. That means we're crossing it right here. So this is the line. This is a solid line, so it will have a solid line underneath. And it looks like this line is being shaded down, so less than or equal to. And finally, we've got this line. It's actually vertical, so we're not shading up or down, we're shading left or right. This is shaded to the left, left is left is less, and since it's solid, it gets a solid line underneath. All right, let's continue on to that last problem. Ooh, okay, this is funky looking. Okay, the first one is just a y and a 5. When that happens, that means, yeah, we are going through the y-intercept of 5, but it's a horizontal line. Since it's dotted, I know I'm not going to have a line underneath. It is shaded going downwards, so less than. The next one has a +6, so I know it's going to be, can't really see that this is the one, but this is the line. Kind of tracing it with the blue. This one seems to be shaded going up. So this one is greater than, and it was a solid line, so it gets an or equal to. That looks awful. I want to rewrite that. There we go. Boom. All right, onwards. The next one has a +9, so that means it's crossing through 9. So that's this line. It's shaded going downwards, so it gets a less than. And our very last line, let's do it. It's this one. It's shaded going to the right, so it's greater than. And that's about it. If you have any questions, please let me or your teachers know. Otherwise, good luck studying and have a wonderful rest of whatever day it is for you. Bye!